guys, it's Miss Adams again. We're going to look at graphing systems of linear inequalities now. So remember, for a system, you're going to have two equations. So remember that systems, we're working with two equations with two variables. We're only going to solve these using the graphing method. So each system has infinitely many solutions that are represented by the intersection of the two shaded regions. So we're now going to graph two linear inequalities on the same coordinate plane, and we're trying to figure out where their shaded regions intersect. So let's look at a couple examples. So this first question says, graph each system of inequalities below. Give a point that is a solution, and then let's give a point that's not a solution. And we're going to say not a solution to the systems, so I'm going to scratch this part out and just do not a solution to the system. So I have y is greater than negative 2x plus 1. I'm going to use this as my first inequality. First off, it's greater than, so I know it's going to be a dashed line because it doesn't equal it. And it's going to be above it. So I'm going to start off at positive 1. I have a slope of negative 2. And I make my dashed line. And normally, we would shade above, so we would have our shading going in this direction. But remember, we're doing a systems of linear inequalities, so our final shading is just going to be a certain region, which is why I'm not going to color in this whole thing yet. So let's look at our second inequality. This says y is greater than or equal to 1/2 x minus 4. Since it's greater than or equal to, it's going to be a solid line shaded above. So negative 4 is our y-intercept. We're going to go up 1 to the right 2 because that is our slope. And we're going to draw a solid line here. And normally, we would shade in the entire region above. But because we're solving a systems, we're trying to figure out where these overlap. So if I'm looking at just where they overlap, we're in this top right-hand region. So I'll highlight it for you guys. So this is the region then that is the solution to our systems of linear inequalities. So let's see if we can find some points here. So let's find a point that is a solution. Let's look at the point 2, 2. This lies in our region, so it is a solution. Now let's look at another point. Let's say I were to use the point 1, negative 5. This is not a solution because it does not lie in our shaded region. This is a you-try problem. I'm going to give you guys a second to try it, and I'm going to be working on it on the board while you're working on it independently. Alright guys, so let's look at inequality 1. We've got y is less than negative 3/2 x plus 3. We have a less than inequality here, so it's dashed and it's shaded below. So I started off at 3 as my y-intercept, did my slope of negative 3/2, so down 3 into the right 2. And I knew it was going to be the region shaded below, but I didn't do my shading yet because I wanted to find the region that that works for both of those, so that covers both inequalities. So then I have inequality 2. It says y is greater than negative x. This is, since it's greater than, is dashed, but it's going to be shaded above the line. So it can be shaded above our green line here. Our y-intercept for our green inequality is going to be at 0 because there's no constant given to us. So I did my slope of down 1 to the right 1, graphed the line, and I found the region that was above the green line but below the red line. So that's what's shaded here in purple. If I find some points, or if I find a point that satisfies this region, I can do the point -1, 2. And if I find the one that doesn't satisfy this region, so it's not a solution to the system, I can do the point -2, -2. Sometimes these will be given to us not in slope-intercept form. So simply just convert them to slope-intercept form. So for this first one, I have y minus 3 is less than or equal to x. I'm going to add 3 to both sides to get y is less than or equal to x plus 3. That's going to be a solid because it's less than or equal to, and it's shaded below. I'm going to start at positive 3, and it has a slope of 1. It's going to be a solid line. And it's everything shaded below. Let's look at our second linear inequality. I want to isolate my y variable, so I'm going to subtract 2 from both sides to get that y is greater than or equal to x minus 2. So my green line is going to be solid, and because it's greater than or equal to, I'm going to shade above. So I'm starting at -2. I have a positive 1 slope. I have a solid line. Notice these lines are parallel because they have the same slope, but I want the region above the green line and below the red line. So this is the region in between. I'm using my highlighter tool because it shades it a little faster. But that's my region in between. And if I were to find a point that satisfies the system of linear inequalities, I do the point 1, 1. And the point that does not satisfy or is not a solution to the system of linear inequalities could be the point 2, -3. And this one also is a U-try problem, but I do want to talk out this problem with you guys because these are special cases. So the first one says x is greater than or equal to 3. I know it's going to be a solid line and shaded above because it is greater than or equal to. So I'm going to find where x equals 3. I'm going to draw a solid vertical line because my x value never changes. We're only changing on our y value. And it's going to be everything shaded to the right since it's above. But remember, we're trying to find the region because this is a system of inequalities. Now let's look at y is greater than -2. This is a dashed line because it's just greater, it's not equal to it. And we also are going to shade above. So I'm going to find where y is -2. And I'm going to have a dashed horizontal line here. Because we don't have a slope, there's no slope. And it's going to be, we're going to shade everything above it, but also to the right of the red line. So the region that is above our green line and to the right of our red line is our top right hand region here. Now let's find a point that satisfies this inequality. So let's say I take the point 4, 1. This is a solution to the system of inequalities. Something that would not be a solution to the system of inequalities, for example, would be 2, -3, because it does not lie within our shaded region. Alright guys, that covers part 1 for graphing systems of linear inequalities. Stick around for part 2.